Metal injection molding is a manufacturing technology that utilizes metal powders combined with organic binders using injection molding technology to produce highly complex structural metal components. Parts are subsequently processed and sintered to yield high-strength, intricately shaped parts. Components produced by metal injection molding are used by medical and dental markets, general industrial markets, firearms, automotive, electronics, miscellaneous other users, aerospace, and automotive. We see here that medical, dental, and general industrial and firearms are the dominant users of metal injection molded components. So one of the questions we ask is my part a good fit for MIM? And here we see in this model material performance, component cost, production quantity, and shape complexity. The closer we can get to the intersection of these four circles, the better the application is for metal injection molding. Powders used in the metal injection molding process are produced from gas atomization. Here we see a model of the gas atomization process. We start with molten metal. Material is then poured into a holding chamber, and from the holding chamber, it is discharged into the atomization area where the molten metal is hit with high pressure gas, inert gas, to produce metal powders. It is then subsequently processed and finished for use. And you can see the spherical nature of the gas atomized powders. This is ideal for metal injection molding because they have a low coefficient of interparticle friction. Metal injection molding process starts with metal powder and binders. Those binders are then compounded into a paste-like material, which is turned into small pellets. This becomes the feedstock that is used in the metal injection molding process. Components are molded in a metal injection molding press. From there, the binders are removed in what we call a debinding process or dewaxing. After the debinding process, the components are sintered at elevated temperatures, typically in the 2350 degrees F or higher in a protective environment or in some cases in a vacuum. And then post-sintering processes are performed as necessary. The gas atomized powder that's used in metal injection molding is put into the feedstock granules, as you can see on the right. The feedstock is then fed into the molding press, where the components are molded under high pressure. After molding, the binder is removed through the debinding process. The typical binders of polyoxymethylene or POM, polyethylene or polypropylene, which are synthetic or natural waxes, and stearic acids are also used as binders. There's a catalytic debinding process, which is an acidic gaseous atmosphere that's used to remove the POM binders as well. We can also use thermal or solvent debinding using acetone, heptane, or an aqueous solution. After debinding, components are then sintered either in a pusher-type continuous sintering furnace or in a batch-type sintering furnace at elevated temperatures, either in vacuum or protective atmosphere. As you can see, in metal injection molded components, we oftentimes see as much as 15 to 20% shrinkage after the sintering process. Some common MIM applications are firearms. Here we see an example of some MIM components that were used in a Smith & Wesson rifle. This is an example of a sound tube that's used in a hearing aid made from 316 stainless steel. And we see the orthodontic appliances using a metal injection molded 17.4 pH stainless steel. Metal injection molding produces intricate components used by medical, electronics, recreation, and other industries. MIM Technologies offers outstanding value for parts requiring intricate geometry and superior material properties.